Good afternoon. I might point out, just as a period on the last couple of talks, that tonight you'll have a chance to see a large super deep diamond at the Smithsonian. So, and it's a blue super deep diamond, in fact. Yeah, that's right. So you can even check out the boron if you want to. That's right. So this session is actually a nice transition into tonight's program, because the title of this session is Making Mineral Collections Relevant in the 21st Century. And being, when you're at the museum this evening, you'll see the public display. What you're not going to see is the 375,000 mineral specimens we have behind the scenes. And saying that, I'm relieved to hear that every talk I've heard today is talking about studying minerals, not just now, but it looks like into the future as well. So it sounds like minerals are going to stay relevant to the science of mineralogy, so we're kind of glad to hear that. We had a workshop at the Smithsonian last fall where we had many of the curators with large mineral collections from around the world address this very topic of what do we mean by keeping mineral collections relevant for the next 100 years. When you think most of the collections we have today have been assembled in the last 100 years by accumulation from various sources, by perhaps a few curators making decisions. And I think looking ahead, one of the questions we'd like to pose, that I think you might think about as you hear these talks, are how do we make these collections more relevant to science in the future? How do we build a partnership between the museums, curators like myself, and the scientists like you that are actually using these collections? I think in the future we have to be much better about building that kind of a partnership so you can help inform us how we should be spending the resources we have. I mean, keeping collections, curating them is not a cheap business. And one of the issues we're looking at is, will all these collections survive in the future? And the more we can make these collections available and relevant to the science of the future, obviously the more secure those collections will be, and hopefully the more valuable they'll be to all of you. So there'll be two different talks giving you sort of perspectives from two of the important collections in the world today. And then at the end of those talks, we'll have a chance to ask questions and discuss this topic. So the first talk is going to be by Kim Tate, who's the curator of the mineral collection and a mineralogist at the Royal Ontario Museum in Toronto. And then the second talk following Kim will be done by Aaron Celestian. And Aaron is at the Los Angeles Museum of Natural History. And so Kim's title is Making Mineral Collections Relevant in the 21st Century. And then Aaron will follow with Unlocking the Collections, Making Minerals Accessible in the Next 100 Years.
I'm Aaron Celestian. I'm from the Natural History Museum of Los Angeles County. I'm the curator there. I am freshly minted curator. I'm there about 4 years. But since then, I've learned a lot. To come from a family of curators, so this is a new experience for me. These are some of my favorite minerals, these nanoporous compounds. We used to call them microporous until that faded out. But this is nice. So we're trying to get comfortable with the next level of access, and I'm trying to explain what that is. But before I do, I want to take a short informal survey. How many of you have in the last 5 years, how many of you requested minerals for research from a museum? That is great. In the last 5 years, how many of you donated materials to a museum? That's more than I expected. That's fantastic. All right, good. So for the rest of you, so these are some of the things I'm going to talk about. So for the rest of you, I'm going to try to inspire you to donate to your museum. So our vision statement at the museum is to inspire wonder, discovery, and responsibility for our natural and cultural worlds. And what that means is a whole bunch of things. And one thing I'd like to take away from it is accessibility. And that could mean lots of different things. So first off, what is our collection like? Our collection is pretty diverse. We've got lots of things. We've got lots of pretty things. These are sapphires from Montana, rough and cut example. And we have beautiful gems, we have jewelry, we have all kinds of things. We have cultural items, we have natural items, we have research items. Behind the scenes that you don't see, and what Jeff and Kim both nicely said, is that we have research specimens. We have about 175 to 200,000 specimens at the Natural History Museum. In the last 4 years, I've had only 20 requests for minerals from our drawers. That's it. This year so far, I've had 2. Not very much. So I'm really trying to see why that is and how can we work together to make the Natural History Museum collection and then all the other museum collections around the world more interesting to you scientifically. Maybe it is already interesting for you and you just didn't know about it. Oh. So one reason why you'd want to donate to a museum is that, one, we have modern analytical capabilities. So if you ask me, hey, Aaron, do you have, I just had a conversation earlier today, do you have pigeonite? And I would like to have a pigeonite of a, approximate composition. I could pull that out of the drawer, I could put it on the XRF and say, yes, there's such and such elements there of interest, and then I can send it off to you. You don't have to come to the museum to analyze them all. And that's highly beneficial, and so that we can sort of thin down what you might need or what you might not. If I don't have it, then I know Kim, I know Jeff, I know lots of other curators around the world. We're highly networked. We'll find the material of interest. You don't have to go to each one of those people. You can just ask one and tell them to go look for each one of those people. We also have infrastructure. We have infrastructure for storage. We have infrastructure for maintaining the collections. We have infrastructure for conserving the collections, for growing the collections, for loaning it out and receiving loans. We have that already built in the mission of the museum. And we have connections with key partners. We have connections with the mines. We have connections with collectors who by far are the best donors to our museum, dealers, researchers, all kinds of people. We have those deep connections. So what does a typical donation to our museum looks like? Well, it looks like this. It's a box of rocks. But this one's particularly important. These are all rocks from a particular mine. So there's a collector in California who goes to specific mines, spends 6 months harvesting minerals and harvesting rocks at each mine, and has a really nice representative material from that mine. And then he donates it all and doesn't ask any questions about how we're going to pay for this. He just gives it to us, and it's fantastic. But you notice they're boxes of rocks. They're not just individual mineral specimens, and that's by far the most material that we have. We have a few just minerals, but most of the time there's a lot of other stuff there that we don't catalog. So if you go to our database online, you'll say, oh, we have quartz. Great. Well, it's quartz plus this, plus this. There might be 6 or 7 other minerals in it, and so I'll get to that point in a second. We also get minerals by people just give us money to buy minerals. We get minerals from other museums, as Kim said. And we also work with other museums. So this is, you might see this. I don't know if this is back on display, Jeff, is it? All right. So we just had a temporary exhibit from Paula Crevichet. She's a jewelry designer, world-famous jewelry designer. Really liked working with her because she's interested about minerals that come out of specific mines. So we tried to tell the story of geology, mineralogy through jewelry. And that captured a lot of attention. That particular specimen, that butterfly, is made out of Montana sapphires. And it's on display right now. We gave it back to the Smithsonian. But it's called Conchita, and that was one of her design pieces. So it allows us to work with other museums, but also educate informally. Our exhibits look like this. And as a typical reaction of a visitor is put their hand on the glass and wish they can grab it. But big aquamarine crystal right there. If you look closely, you can see my ominous figure standing over guard in the reflection of the glass. Terrible picture. But one thing that we do is we display Earth's beauty, and that's kind of, unfortunately, a lot of visitor experience stops there. And it's challenging to take them past that point, especially in some older museums and older collections. But we also provide space for the community. We provide space for discussion. And this is a very safe space for the community because we really work with them a lot and encourage that. We provide lots of learning opportunities, workshops, and such and such and such. And we're trying to build that community we're trying to really build that relationship with the public because it's the public who gives us our vast majority of our specimens. And they're the ones that give us money to keep going. And they're the stakeholders in if the museum continues to persist or not within the community. And we share current research interests. So not only do we share research specimens, but we also share the research that we do with them. Databases can be improved. There's a lot of databases out there. There's more than I can possibly search. Rough is great. Worm is also good. MinDat is also good. A lot of those were started by private money, though. They never not started by government funding. So we digitize our database so you can see even what we have, and that's it on the left, that's the user interface, it's not very good. And we need to definitely improve that. And we're also working on ways of including data, actual data from minerals in that database. But data entry is laborious. You have to have an army of people to transcribe 1880s cursive, and 1880s location information would have changed in the now 2019. Some countries exist and some countries don't. Some mines exist and some mines don't. You have to figure out where these things came from, and that's definitely challenging. And you also have to take the collector's word for it that it is that particular specimen. So if you get a donation of 20,000 specimens, I cannot go through each one of those 20,000 specimens and make sure that it is what it is. So there's lots of those built-in errors in our database. Spelling errors too, that's an atrocity. That's terrible. Oh yeah, there it is. Accuracy, acquisition, where did these things come from? Did they come from the mine that they say they come from? Sometimes they don't. There's a mine in California where there's emeralds. I have no idea where it is. The mine owners keep sending me material, but I have no way of putting it in our collection because he refuses to divulge the information. Because if it becomes public, then it's a problem for him. So there's things that we do share and some things that we don't share. And it'd also be nice to have some community contributions. It'd be nice to have somebody point out where our spelling mistakes are. It'd be nice to have somebody say, hey, Aaron, I don't think that's mesolite, I think it's naturalite, or something like that. And it's like, okay, great. Then I can go back and look at the collection and see if I can make those judgment calls or collect the data to do it. Who has access to these collections? So up here in the top left is our diamond reference drawer. We have 4,000 reference diamonds. Since I've been there, nobody's requested them. They're not very big. They're some of our bigger ones in the reference drawer, 3 or 4 carats in size. A lot of twinned, Mackle twins, intergrowths, things like that, different colors, different fluorescence properties, and phosphorescence properties. But we have really two main groups that we serve with our collection. We serve the scientists, talk about them first. We loan these out, usually by mail. Sometimes people come to our museum and do research. So we have student collection grants that we award students to come to the museum to work in our collections. I know not everybody can come to a museum to do it. So we pay people to come to our museum to work on our collections. But mostly the loans that we give out are by mail. And if you're going to do non-destructive analysis, you're guaranteed to get the material pretty much. If you're going to do destructive analysis, then we have to talk a little bit. But we do have some current limitations. One, we often don't have what the researcher needs. So a researcher might need a particular specimen from one isolated spot in the world. We may have that specimen, but not from that location. That is a common thing. Plus also the rarity of certain species also prohibit destructive analysis. We have I must say it, we have the world's rarest gemstone. It's called chatuite. Anybody heard of it? 3 people, 4 people, great. It's the only example of chatuite that we know of in the world, and it's in our collection. And until they find more, it's a 1.6 carat stone. It's a big stone. There's got to be more of it out there. It's from Mogok. It's got to be more, but nobody's ever found any more. So doing destructive analysis on something like that is a little bit trickier to work out. But I am all for it. So the public-facing interface, this is the outside of our museum. The public only gets a limited viewing of the collection. The public only gets what we think is the most important. So there's some bias there. I'm going to start putting out a lot more zeolites coming up. And also the kind of information that we give them is limited in scope. We don't provide every sorts of learning, educational opportunities. We do provide learning opportunities, but most of the time you have to come to the museum. And that's a problem. That's where putting things online becomes a little bit easier. Putting data online where people don't have an instrument, but they need Raman data or they need X-ray diffraction data. Put that stuff online so you can really spark interest and inspire people and inspire discovery. But most of the public, we take informal surveys at the museum, and most public don't even know why we have collections. They think that these minerals, maybe they were carved, maybe they were synthesized. They don't even know why we even bother collect these particular specimens. And that's something that has to change if the museum collection is going to continue to survive for the next 100 years. All right, so what do the researchers need? Well, the researchers need access, clearly, but they also need to share information. And this is why we publish things. But in a museum, what things mean for sharing is that if a person borrows specimen X and collects data on that and then deposits that data into some repository, and person B also collects this data on that particular sample and deposits in a repository, that specimen X becomes much more valuable. It becomes much more valuable to the researchers because now there's data history on that you have something, you can take the specimen and compare your analyses to that's from the museum. I mean, everybody knows this. I'm preaching to the choir, but I think it needs to be said again because of my experiences at my museum. So specimen X becomes much, much more valuable. But that data is also valuable too. So there's a person C working on a mineral, some Y, and deposits. Maybe they didn't publish the paper. Maybe it's like, I don't know, I'll just get this out there. I'll just deposit the data in a preprint server, write up a short little blurb, and put it out there. That's uncommon in geology, much more common in chemistry, astronomy, and physics, but it's becoming more common, I think. And then person D is working on a mineral Z. That's what the mineral Z and Y are very, very much related. And they find this preprint server and collect and write up a paper. And ChemArchive is a common preprint server. And then person C gets more citations. Then those minerals become much more valuable again. So not only is getting the data out there into databases useful to the museum, but it's also useful to you as researchers because we have to justify to our deans and our VPs for research and collections how many citations we have. And unfortunately, those numbers persist even till this day. But it is bean counting for the bean counters. But the museums play an important role in housing these materials. We're not necessarily great at housing the data. That's for other places. But we're great at housing the materials. But if we had a centralized database that told researchers, hey, this mineral specimen's over in LA, that mineral specimen's in Toronto, the data is on this server, the data is on that server in a centralized location, then it would become much easier to use, and I think the usage of museums would increase. So an example of access, this is trouble. I'm working on a rare mineral, and I need to be able to get something of it, but I know it's scattered about all over the planet. How do I get access to this mineral? I can't go to each one of these places and collect the data. Even if I had money to do that, I wouldn't want to go to those places. I might go to one or two, but I want a more representative sample. Well, here's the locations of all the museums. Not all of them, some museums around the world. And I'm pretty sure that some of those museums are pretty close to some of those localities. So not one museum is going to have every specimen that you're interested in, but the network of museums will have a very powerful collective database. And if we can share that more, right now we're not, if we can share that more, then I think finding minerals where you want them to be from for your research will be easier to find. So what's next? Well, this is a newspaper from June 20th, 2119. But what's next is how will techniques really reevaluate what we know? I am under constant pressure to deaccession things from my museum, but I am terrified to do it because I don't know what's in that drawer hasn't yet come to realization of being scientifically important. I don't want to just throw something away because it is a quartz crystal with some yellow things inside of it. I want to hang on to that because I don't know what the new techniques are going to be like 100 years from now that say that quartz crystal is really, really important. So I need space to do that. So which minerals will be important for future research? I just kind of answered that question. And we also need links to raw data in the databases. And this is something that I'll address next. So why not share collections? Why do you let important minerals sit in a drawer? And don't let your synthetic minerals go. Those are important too. I did my whole entire PhD dissertation making my own minerals because I couldn't find enough to do my work on. And when I left Stony Brook, I'm sure some of those minerals got thrown in the garbage because I put a bunch of notebook numbers and stuff on the outside of my vials, labeled it with a chemical composition and not mineralogical information, and I thought that was fine. It worked for me at the time, but when I left, I'm sure somebody said, I don't know what that is. That's hazardous waste. Let's get rid of it. That definitely happens more times than you think. But somebody did a study on this. This was published this year in Nature. And this is not mineralogy, this is paleontology, but I think we can get some useful information out of this. In 2017, 2018, this group decided to look at the 200 most popular paleontology papers that had 3D scans in them. 59 of those 200, 200 papers, 200 total papers, and 59 of those had 3D scans. Okay, so with paleontology, 3D scans are really important. In anthropology, 3D scans are really important because you just have one fossil. There is no duplicate fossil, you just have that one. Even if you went to the same place, it's a different fossil. And so they take those 3D scans and they can make measurements about physiology, about all kinds of stuff from that. Same thing with archaeology and anthropology. They take these 3D scans, but people hoard them, and the researchers don't let go of these 3D scans. Even though they're digital, they still don't let them go. So of those 59 paleontology papers that had 3D scans, so 31%, only 31% shared the data online. And I think from my experiences in the museum, I think that would be extraordinarily generous for a group of scientists to share that data. And it's expensive data to get those 3D tomography scans and get those 3D images. It's not cheap. 66% did not share, and 3% followed up the data with another paper. But why didn't they share? So they asked those questions. Why didn't you share the online data? Embargoed for future work. So I don't want to get rid of it yet, and I may need that digital 3D scan in the future. You can still keep it. You just share the data, but they didn't want to do that. Common thing is just not even answer the question. Just move on. Not required to share. Well, that's fair enough. Copyright restrictions, not sure what that means. Not necessary to replicate findings. Oh my God. And it just gets worse from there on out. Didn't know how to share, that's fine. Intend to share, good work. Confidential, didn't think about it. Co-author didn't share. So I think some of that stuff it echoes in the mineralogical community as well. So if you had all this data, and if you had access to these mineral collections, what would you do? Well, it'd be great to just sit down in front of a computer. There's your desk. Sit down in front of your desk. Pull up a web browser. This is a web browser that I found that was from GBIF, which is the Global Biodiversity Information Facility, and I renamed it. And you can collect data, you get all your X-ray diffraction data from it, you get your Raman data from it, and so on, and write up your preprint, and then finally put out your super cool mineral paper. And then that's it, right? But I think in the end, what really happens is that you still need access to that mineral specimen. Even though you can download all that data, I think all of us agree that you still need access to that one specimen. To continue to push the limits of our analytical capabilities, to continue to push the limits of science, we still need access to that stuff. So with that, I would like to say, like, in the next 100 years, that's how I'd like to see mineral collections go, is much more collaboration between you and us. Thank you.